When you try to understand the origins of life, you really have to have a very large framework to start with. And the first thing you need to understand is, how do stars really form in the first place? Obviously, you're not going to get any life without some sort of energy, some sort of star. Now, the first step in this particular exploration, I think GALEX illustrates very well.
GALEX is a low-cost mission. It's a small explorer. Traditionally, the small explorers are launched from a small rocket called a Pegasus. And it flies out of the upper atmosphere as its first stage, and then it has a more conventional second and third stage. The main objective of GALEX is to measure the star formation rate in galaxies. And it turns out that to measure the star formation rate, we need to look at only the very hot stars that have a short lifetime. Looking at a galaxy with GALEX is like taking a picture of a crowd of people and having everybody over the age of 5 suddenly disappear from the picture. You're left with just the very young stars that tell you how active star formation is in a galaxy.
One of the best moments in this project for me was early on, maybe a few weeks after launch, when we had the instrument turned on and saw our first picture of the ultraviolet sky from the Galaxy Evolution Explorer. And it was filled with galaxies. And it was just a 2-minute picture, just a short amount of time. And yet we already saw that the universe was filled with galaxies luminous in the ultraviolet. And here we were looking at 1/40,000th of the sky. It was an amazing, thrilling moment. It's exactly what I had always hoped and dreamed for, but you never quite believe you're going to get there, and there we were.
The Spitzer Space Telescope shows us the universe in an entirely new way of looking at it: infrared light. Infrared light shows you some very specific and interesting astronomical things, like young stars or black holes in the very hearts of the most active galaxies are shrouded by dust. And that makes them completely invisible to the sort of light that our eyes see, visible light. But infrared light gives us a view inside these mysterious areas, and we're getting the clearest views we have of that for the first time.
You're sitting somewhere in your house on a weekend and you realize while you're sitting there, Spitzer is very far away, pointing at sources, taking fabulous images. Twice a day we're sending these things down all across the globe through the Deep Space Network. It truly is remarkable. We're looking at things that happened so long ago and are happening so far away.
I think we're going to get a much, much better understanding of the formation and prevalence and evolution of planetary systems within our galaxy. And I think we've already learned some things about the dust component of the planetary systems that are kind of going to change our view of the processes which might have influenced the early Earth. Spitzer is a technological precursor to a lot of future NASA missions. So we kind of crossed a lot of technical divides, and people will never look back to the old way of doing things.